I wanted to make one more comment about this problem before we move away, which is this has some really big implications for us. I mean, the probability of having at least one boy is really, really, really high. The chances of all girls, which now that I think about it, it was a friend of my grandmother's that I went to this party with, but still, they had 12 girls, and the chances of that are just really, really, really low, namely 0.00024 or so. Okay, so and this method right here is just going to get used all the time. When you want at least one of something, you find the probability of none of that and take it away from 1. That's a whole lot easier to find. And remember, it's 50-50 to the 12th power. Now, that's give us implications over here. So the No Child Left Behind Act of 2001 mandates that by the year 2014, each public school must achieve 100% proficiency. That is, every student must pass a proficiency exam or the school faces serious sanctions. Suppose that students in a particular school are all very competent. For each individual, the probability that they will pass the exam independent of either classmates is 0.99. Now, of course, in any school, independency is actually really hard to come by, but for our purposes, we're just going to go with it. So if there are 500 students in the school, how many do we expect to pass? Well, that's just 500 times 0.99, which would be 495. Right? Cool. All right, so 500 times 0.99. So what is the probability that everyone will pass? All right. Probability that everyone will pass. Okay, so every person has a 99% chance of passing. That is so high. So 99 times, another next person would be 99, times the next person would be 99, and so on. Okay, and you'd have 500 of them, so it would give you 0.99 to the 500. Right? Really, 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 really high. I don't even know if Excel will do it. Let's go see. Equals, not that one. There it is. Equals 0.99 to the 500. There it is. So really high, 0.00657. So let's try that. Or excuse me, really low. Now check that out. You have a 99% chance for any one person. You expect 495 students to do well, which of course no school actually has 99% competency, but bear with me here. So if that's the case, but 99 times 99 times 99, 500 times, means you only have a 0.006% chance, right? Which would be 0.6% of your school actually passing these proficiency exams, because everybody has to pass. No student, no child can be left behind. Get it? So, but you have like a 99.4% chance that some kid's going to get left behind, even if your school has it so that every kid in your class is really, really smart and has a 99% chance of passing this test. All right, so what does that mean for, oh, by the way, this is very, very unlikely that all students will pass and no child will be left behind. Get it? All right, what is the probability that at least one of the 500 students will not pass the proficiency exam? Okay, so the probability of at least one will not pass. Remember that at least one. That's 1 minus, I'm going to write it down here, 1 minus the probability that none will not pass. Which is kind of weird, but it means that that's the way complements go, right? So you have to say at least one will not pass. So none will not pass, i.e. 1 minus probability that all pass. Oopsie. But we already found that number. It was 0.006. So equals 1 minus 0.00657, which is 0.99343. So there's a 99% chance that somebody is not going to pass, right?